Hello everyone, welcome to Squadmath. Today we are going to learn about integers. I am your host Yamna and I will guide you through this important topic. Integers. Integers are a set of numbers that include all whole numbers. Whole numbers means positive numbers. Their negative counterparts means negative whole numbers and zero. The integer set includes positive integers. These are the natural numbers greater than 0 like 1, 2, 3, 4. Negative integers. These are the opposite of positive integers like -1, -2, -3, -4, etc. 0. The integers that represent no quantity or value. The set of all integers is denoted by capital Z. Capital Z is equal to set of -2, -1, 0, 1, 2. Number line representation of integers. The plus and minus sign before a number tells on which side the number is placed from 0. Minus. Symbol in front of a number is read as negative or minus. For example, -5 is read as -5 or -5. Number line representation for integers. See 0. The positive integers extend from right of the 0. Negative integers extend from left side of 0. Write all the integers between the given number 7 and 10. See number line -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See how many numbers are in between 7 and 10? 8, 9. Two numbers are in between 7 and 10. Right. 8, 9. Write all the integers between the given numbers -5 and 4. Count how many numbers are there? -4, -3, -2, -1, 0, 1, 2, 3. How many numbers are in between -5 to 4? 8 numbers are there. Right. -4, -3, -2, -1, 0, 1, 2, 3. Next, -3 and +3. Count -2, -1, 0, 1, 2. Right. -2, -1, 0, 1, 2. Next, -5 and 0. How many numbers are in between -5 and 0? -4, -3, -2, -1, 0. Write down. -4, -3, -2, -1. Next. On the number line, which number is 4 units to the right of -7? From -7, we can first draw the number line. -7, -6, -5, -4, -3, -2, -1, 0. From -7, we can move 4 units to reach -3. So the required numbers are -6, -5, -4, -3. The answer is -6, -5, -4, -3. Next, on the number line, which number is 5 units to the left of 3? Draw the number line. -3, -2, -1, 0, 1, 2, 3, 4. From 3, we can move 5 units to its left to reach -2. So how many numbers are there? 2, 1, 0, -1, -2. Write the numbers. 2, 1, 0, -1, -2. Predecessor and successor of an integer. Find the predecessor and successor of the following. Integer -7. Its predecessor is -8. And its successor is -6. See, -3. Its predecessor is -4. Its successor is -2, 0. -1 predecessor, successor is +1. 4, its predecessor is +3. And its successor is +5. 7, its predecessor is 6. And its successor is 8. To understand easily, 7 to predict predecessor -1. So 7 minus 1, 6. Successor, we want to add +1 to 7. We get 8. Opposite of a number. The opposite of a number is the number itself. For example, minus of -5 read as negative of -5, or minus of -5 is equal to 5 itself. Find the opposite of the following numbers. 44. Its opposite is -44. -19. Its opposite is 90. To understand clearly, see the number line 0, 1, 2, -1, -2. -1 is opposite of +1. -2 is opposite of +2. See, 0 is number itself. -312, its opposite 312. 789, its opposite -789. Comparing integers. Put the appropriate sign as less than, greater than, or equal to in the box. -7 is less than 8. -8 is greater than -7. 999 is greater than minus 1000. Minus 111 is equal to minus 111. 0 is greater than minus 200. Ordering integers. Or arrange the following integers in ascending order. Minus 15, 0, minus 7, 12, 3, minus 5, 1, minus 20, plus 25, 18. Solution. Step 1. First, separate the positive integers as 12, 3, 1, 25, 18 and the negative integers as minus 15, minus 7, minus 5, minus 20. Step 2. We can easily arrange the positive integers in the ascending order as 1, 3, 12, 18, 25 and arrange negative integers in ascending order minus 20, minus 15, minus 7, minus 5. Step 3. As 0 is neither positive nor negative, it says at the middle and now the arrangement is minus 20, minus 15, minus 7, minus 5, 0, 1, 3, 12, 18 and 25 in the ascending order. 4 fundamental operations on integers. The 4 basic arithmetic operations associated with integers are addition of integers, subtraction of integers, multiplication of integers, division of integers. Adding integer rule. Case 1. Signs are same. If the signs are same, add and keep the same sign. Positive integer plus positive integer. Add the numbers and the answer is positive. For example, 2 plus 5 we get another positive number 7. Negative integer plus negative integer. Add the number and the answer is negative. For example, minus 5 plus minus 4 we get minus 9. Case 2. Signs are different. If the signs are different, subtract the numbers and use the sign of the larger number. Positive integer plus negative integer. Subtract the numbers and take the sign of bigger number. For example, plus 7 plus minus 3 we get 4. Plus 4. Here bigger number is plus 7. Negative integer plus positive integer. Subtract the numbers and take the sign of bigger number. For example, minus 9 plus 6 we get minus 3. Here the bigger number is minus 9. So we putting negative sign. And 9 minus 9 plus 6 we get 3. Subtracting integer rules. To subtract a number from another number, the sign of the number should be changed and then this number with the changed sign should be added to the first number. Positive integer minus positive integer. Change the sign of the number to be subtracted and then add up. The result takes the sign of the greater number. For example, plus 6 minus plus 2 we get plus 6 plus minus 2 is equal to 6 minus 2 is equal to 4. Negative integer minus negative integer. Change the sign of the subtracted and add them up. The result takes the sign of greater number. Example, minus 9 minus 6 is equal to minus 9 plus 6 is equal to minus 9 plus 6 is equal to minus 3. Plus minus negative integer is equal to change the sign of the number to be subtracted and add them up. For example, plus 5 minus 3 plus 5 plus 3 is equal to 5 plus 3 is equal to 8. Minus negative integer minus positive integer. Change the sign of the number to be subtracted and add them up. Result is always negative. For example, minus 2 minus plus 2. We get minus 7 plus minus 2 is equal to minus 7 minus 2. We get minus 9. Multiplying and dividing integers rule. Case 1. Signs are same. If the signs are same, the answer is always positive. Plus positive integer into positive integer, positive integer. 5 into 4 we get 20. Positive integer divided by positive integer, we get positive integer. Example, 16 divided by 4, we get 4. Negative integer into negative integer, we get positive integer. For example, minus 7 into minus 9, we get 63. Positive plus 63. Then, negative integer divided by negative integer, we get positive integer. For example, minus 20 divided by minus 2, we get plus 10. Multiplying and dividing integer rule. Case 2. Signs are different. If the signs are different, the number always negative. Positive integer into negative integer will be result. Example, 6 into minus 10, we get minus 60. Positive integer divided by negative integer, we get negative integer. Example, 30 divided by minus 15, we get minus 2. Negative integer into positive integer, we get positive integer. For example, minus 3 into plus 11, we get plus 33. Minus 33, here minus 33. Minus divided by plus, we get minus. Example, minus 25 divided by 5, we get minus 5. Rules of integer. Rules defined for integers are sum of two positive integer is an integer. Sum of two negative integer is an integer. Product of two positive integer is an integer. Product of two negative integer is an integer. Sum of an integer and its inverse is equal to 0. The product of an integer and its reciprocal is equal to 1. Properties of integer. The major properties of integers are closure property, associative property, commodity property, distributive property, additive inverse property, multiplicative inverse property, identity property. Closure property. According to the closure property of integer, when two integers are added or multiplied together, it results in an integer only. If a and b are integers, then a plus b is equal to integer, a into b is equal to integer. For example, 2 plus 5 is equal to 7. 7 is an integer. 2 into 5 is equal to 10. 10 is an integer. Commodity property. According to commodity property of integer, if a and b are two integers, a plus b is equal to b plus a. A into b is equal to b into a. Example, 3 plus 8 is equal to 8 plus 3. LHS is equal to LHS also 11, RHS also 11. 3 into 8 is equal to 8 into 3. LHS is equal to RHS, both 24. But for the commutative property is not applicable to subtraction and division of integers. Associative property. As per the associative property, if A, B and C are integers, then A plus B into B plus C is equal to A plus B into plus C. A into bracket B into C is equal to open bracket A into B close bracket into C. Examples, 2 plus bracket 3 plus 4 is equal to bracket 2 plus 3 plus 4 is equal to 9. LHS is equal to RHS. 2 into bracket 3 into 4 is equal to 2 into 3 close bracket into 4. We get 24. Similar to the commutative, associative is applicable for addition and subtraction of integers only. Subtraction and division does not exist in associative and commutative property. Distributive property. According to the distributive property of integers, if a, b and c are integers, then a into bracket b plus c is equal to a into b plus a into c. Example, prove that 3 into bracket 5 plus 1 is equal to 3 into 5 plus 3 into 1. LHS, 3 into 5 plus 1 is equal to 3 into 6. First add the numbers in bracket. We get 6 and multiply the numbers. Second, we get 18. RHS is equal to 3 into 5 plus 3 into 1. 15 plus 3 is equal to 18. LHS is equal to RHS. Hence proved. Additive inverse property. If A is an integer, then as per the additive inverse property of integers, A plus bracket minus A is equal to 0. Hence, minus A is the additive inverse of integer A. Plus A minus A cancel. So, we get 0. Hence, minus A is the additive inverse of integer A. Multiplicative inverse property. If A is an integer, then as per the multiplicative inverse property of integers, A equal to bracket 1 by A is equal to 1. This A and denominator A will be cancelled, remaining 1. Hence 1 divided by A is the multiplicative inverse of integer A. Identity property of integers. The identity elements of integers are A plus 0 is equal to A. A into 1 is equal to A. In addition, if A equal to 9, 9 plus 0, we get 9. In multiplicative identity, A into 1. 1 is the multiplicative identity. If A equal to 9, A into 1 is equal to 9. Properties of integers. The properties of integers. Property name. Closure property. Addition, subtraction, multiplication. Three operations will be exist in closure property. Division property sometimes does not exist in closure property. Commutative property. A plus B is equal to B plus A. Addition property exists. Subtraction does not exist. Multiplicative operation exists in commutative property. Division does not exist in commutative property. So, addition and multiplication only exist in commutative property. In associative, also subtraction and division does not exist. Only addition and multiplication exist in associative property. In identity, addition and multiplication only exist. Distributive property, addition and subtraction only exist. Important facts. The number line can be shown both in horizontal and vertical directions. The number 0 is neither positive nor negative, hence has no sign. Natural numbers are called positive integers. Whole numbers are also called as non-negative integers. Positive and negative integers together are called as signed numbers. They are also called as directed numbers. A number without a sign is considered as a positive integer. For example, plus 5 is considered as a plus 5. The letter Z was first used by the Germans because the word for the integer in the German language is javelin, which means number. The sum of two positive integers is positive and sum of two negative integers is negative. Sum of a positive and a negative integer is the difference of two numbers n value and has the sign of the greater integer. Division of integers is inverse operation of multiplication. Product of two integers is minus 135. If one number is minus 15, find the another number. Answer. Given AB equal to minus 135. Product of two integers. And A equal to, if one number is minus 15, A equal to minus 15. Substituting minus 15 into B, we get is equal to minus 135. B equal to minus 135 divided by minus 15. B equal to 9. 9 15s are 135. Minus and minus divided by minus, we get positive. Thanks for watching. Don't forget to subscribe, like and share.